Okay, so the snow's got us all messed up, and we still need to cover all this material. So what I thought I'd try to do is to take the PowerPoint presentation and put it up onto YouTube to see what happens. So tonight we'll talk about the bivariate measures of association, get some hot chocolate, grab a glass of vino, Pinot Noir is good, sit back, relax, and soak in the presentation here. Okay, so when we think about measures of association, these are the measures of association from the type of association you looked at when you talked about time order, non-spuriousness, and association, looking at causal validity. And this follows up from what we looked at in terms of cross-tabulations, in the contingency analysis, and the elaboration paradigm, in that was looking at bivariate association. So we're just continuing on with that. But I want to basically give you a bit more theory and kind of talk about what underlies all of that. And so what we're looking at here basically are the different properties of a bivariate relationship. Now, for there to be a bivariate relationship, we could talk about the existence of an association. Is there an association or not? We can talk about the strength of an association. So how strong is the association? And then what's the direction of the association? So how does one variable change with the other variable? And so what the measures of association do is they summarize those three properties of a bivariate relationship. So we could boil it all down into one number. Okay, so how does this work? Essentially what we're doing with these sort of measures of association is trying to figure out how much does the addition of information from one variable increase the chances of correctly predicting the value of another variable. That's what you see in the equation there. So we're judging the strength of a relationship between two variables by asking how much knowing values on one variable would reduce our errors in guessing values on the other variable. To put this in human terms, if we know whether or not someone owns a dog, we should be able to improve our ability to estimate their stress levels. And if we do that, it will indicate that there is an association between those two variables. Here's how this works. On average, we see here that half the people are stressed. So without any other information, I would just guess that someone is stressed, and on average, I would be right about half the time. Now, you add the information, give me another variable, you tell me whether or not they own a dog or not. I'm going to guess that if they own the dog, they're going to be less likely to be stressed. And as we see on the top table there is an association. Those individuals who own dogs are more likely to be not stressed. And we see that basically there's a 40% reduction in error in guessing stress when knowing dog ownership. Now, you look on the bottom table there, we see that there's a much stronger association. And when you do the math on this, we find that there's an 80% reduction in error in guessing stress when we know whether or not an individual owns a dog. Using this logic, there are a couple of specific measures that are based upon the proportionate reduction in error to measure association. If you have a nominal variable, if at least one of your variables is nominal in terms of having two categorical variables, you're going to use what we call lambda. And it's based upon our ability to guess the values on one of the variables. So when we looked at the example of guessing whether or not somebody's stressed on whether or not they have a dog, that's what we're looking at. We're looking at lambda. The other measure we look at is when we have ordinal variables, we use gamma. And these are based upon guessing the ordinal arrangement of values in a table. And you guys have worked with this and working with your workbook. But we'll go through them anyway just to make sure you get it. The most basic of these measures is lambda. It's a proportionate reduction in error measure that we use to determine the level of association for nominal variables. So our level of measurement is when we have both nominal measures or one is nominal and the other is ordinal. It's based upon our ability to guess the values on one of the variables, and it's what we call an asymmetric measure. In other words, its value might change depending upon which variable is independent and which variable is dependent. So one of the things you'll have to do when you're interpreting your SPSS output is pay attention to which variable is a dependent variable, because SPSS will calculate it for both of your variables to determine which is independent and which is dependent. In terms of the three different properties we talked about for a bivariate relationship or bivariate association, in terms of the existence of an association, if lambda equals 0, it means that no relationship exists. If lambda is somewhere between above 0 and 1, it means that a relationship exists. The second thing we can look at is the strength of the relationship. And what you see there is the table that we have. So it's between 0.01 and 0.1, we talk about it in terms of being a weak association. If we look at it in terms of 0.11 to 0.3, we talk about it in terms of moderate. And if it's between 0.31 and 0.1, we talk about it in terms of being a strong association. The other thing we look at is the direction. There's no measure for the direction of association with lambda. You kind of have to look at the contingency table, look at your crosstab, and figure out what's the direction here, because lambda doesn't give you a positive or a negative. As an example, we can look at a comparison between Canadians and US Americans in terms of whether or not they prefer freedom or equality. If you look at the cross tabulation, we see that Americans are more likely to value freedom than Canadians are, or Canadians are more likely to value equality than Americans are. The lambda on this, when you calculate it, is a fairly weak value. It's 0.09. Since your workbook does a pretty decent job of dealing with lambda, I'm not going to spend a lot of time talking about it, except to reiterate one of the points it makes about what happens when lambda equals 0, in that you need to be cautious when you get that value and don't interpret it as there not being an association necessarily. Because when lambda equals 0, sometimes it's not because there's not an association between the two variables. It's because the total of one value on the dependent variable is much larger than the total of the other value on the dependent variable. So you may have an outcome that is 90% one value and 10% the other value. And even though you may have an association there, because of that difference where the variable totals are substantially dissimilar, you may have an outcome of a lambda equals 0. So what do? We'll use SPSS and calculate what we call a chi-squared base measure of effect. Now there's two of these. One of them is when you have a 2 by 2 table, so two dichotomous variables, and you calculate what they call phi, as in phi, phi, pho, fum. When the relationship is larger than 2 by 2, so if you have a nominal measure that has 3 categories, or a nominal measure that has 4 categories, and an ordinal measure that has 3 categories, or whatever, you use what they call Kramer's V. And SPSS will also calculate that for you. The first of these measures is phi, the chi-squared base measure of association, and we're only going to use this when we have a 2 by 2 table. Now it's real easy to calculate, even though SPSS does it for you. Basically what it is, you're dividing the chi-squared value you get by the number of cases that you're examining, and you take the square root of that. Now, you're going to get a value, and you're going to want to know, how do I interpret this value? Well, basically, if it's between 0 and 0.1, we talk about it in terms of being a weak association. If it's between 0.1 and 0.3, we talk about it in terms of being a moderate association. And if it's above 0.3, we consider that to be a strong association. To see phi in action, we can return back to our example of Americans and Canadians in terms of their preference for freedom or equality. And when I run phi on that, based upon the chi-squared value and the number of cases, I see, first of all, that there is an association. In other words, phi is above 0, so that tells me that there is an association. It exists. The strength is a 0.11, so according to the chart we looked at in a previous slide, it shows that there is a moderate association. And in terms of the direction, we have to do the eyeball test, and we see that Americans are more likely to value freedom. Kramer's V is the chi-squared base measure of association that we use when we have tables that are larger than 2 by 2. Now, as you can see from the formula, then this is something that SPSS will do for you. I'm just putting it there to give you a taste of where this measure is coming from. Kramer's V is basically just the chi-squared value that you get that is divided by the number of cases. Then you multiply that by the minimum value of either the number of rows minus 1 or the number of columns minus 1. Now, with Kramer's V, we interpret the strength the same way that you interpret the strength of phi, and that's just what we saw in a few slides before. If we add a country to our example of preference for freedom versus preference for equality, so we'll put France in there, we see basically the chi-squared value and the number of cases and the number of rows and number of columns, and SPSS does all this for us. It gives us a Kramer's V value of 0.31, which, according to the criteria we talked about, that's a fairly strong association. So we know that association exists, it's above 0. Based upon the value, we know that it's strong, and just interpreting the direction, we would say that Americans are more likely to value freedom, whereas the French are more likely to value equality. Running phi and Kramer's V in SPSS is fairly straightforward. You get them when you're doing cross tabulations, and you select them using the statistics dialog box that you use when you're using cross tabulations. So it's the same box that you would use to get lambda, that you would use to get gamma, and so forth. And it's just a single checkbox. SPSS calculates them both at the same time. So you click that, hit continue, and run your crosstabs, and in your output, you'll get the phi or the Kramer's V in your output.